Good morning. In this problem, we're asked to write the equation of the hyperbola in standard form. So a couple things before we start. The first is to understand that this must be general form. The way that I think about general form for any of the conic sections is to understand that general form is basically everything multiplied out. So this is in general form. The second thing is, if this problem didn't tell you that this was a hyperbola, what defining features of the equation would tell you it's a hyperbola? So looking closely, it's important to understand, if I look at the x squared term and I look at the y squared term, a couple things give this away that this is a hyperbola. Well, really just one thing gives it away. The key thing that gives it away is that there's a minus sign in front of one of the squared terms, okay? So why can't this be a circle? Remember, circles had a positive x squared and a positive y squared, and the coefficients in front of the circles matched exactly, right? So this can't be a circle by that logic. Is it an ellipse? Well, to be an ellipse, remember, you needed different coefficients in front of the x squared and y squared, but remember, for the ellipse, you needed both of them to be positive. So this basically has to be a hyperbola using that logic. You might also ask, why isn't this a parabola? Well, for us to have a parabola, I'd need either just one x squared term and no y squareds, or I would need a y squared term with no x squared. So this has to be a hyperbola, and that's something you should just understand. So what I'm going to do to put this in standard form is I'm basically going to complete the square just like I did with the ellipse. It's really the same process. So the first thing I want to do is I want to move the 36 to the other side. So I'm just going to move this over. That's going to equal a positive 36. And then I want to organize my x's and my y's all together. So I start with my x squared term. So I have x squared. And I find my other linear x term. So where's that? Oh, negative 4x. And I put those together and I put a plus blank. Then I organize my y squareds. So I have minus 4y squared. And then notice I have a plus 24y plus blank, okay? And remember, because I have an equation, whatever I do to the left side, I have to do to the right side. So if I added 2 blank spaces on the left to balance the equation, I need to add 2 blank spaces to the right. So this is basically exactly the same setup as the ellipse. Now, what I want to do is I want to take this imaginary trinomial, right? And I want to put a number here that makes this trinomial able to be written as a binomial squared. So I take my coefficient in front of my linear term, right? I say, what's negative 4 divided by 2 squared? That's going to be 4. I'm going to add a 4 to the left and a 4 to the right. Now, how do I write x squared minus 4x plus 4 as a binomial squared? I'm going to write that as x minus 2 quantity squared. Okay, now I'm going to do the same thing here. I'm going to, okay, so actually let me just talk a little bit about how to make this easier. I'm going to show you like a cool, easy trick. If I look at negative 4y squared plus 24y, right, you might be thinking, oh, so annoying, I have this negative 4 here. So what I would recommend, and so maybe this is a little harder than the ellipse, but I would factor out the negative 4. So watch this. Okay, so see what I'm doing? I'm factoring out the negative 4. And I would make this y squared minus 6y plus blank. Okay, so does that make sense? I'm taking the negative 4. If I multiplied it back, I'd get what I have up here. You'll see this will be so much easier. So factor out the negative 4, and specifically the negative 4. Okay, now let me just write 36 plus 4 plus blank, because I still need to fill that in. And I'm going to now sort of complete the square just on the stuff in parentheses. So take the negative 6, divide by 2, and square it. What does that give me? That gives me 9. So I'm going to put a 9 here. But you want to be really careful with what you add to the right side. You don't just want to add a 9 to the right side, right? Because technically this 9 is going to be multiplied by -4. So really what you want to add to the other side is -36, right? Because this would be -36 if I multiplied it out. So I'm going to put a -36 on the right. Okay, now I'm just going to clean this up a little bit, right? Let's go down here. This is the quantity x minus 2 squared minus 4, okay? And I'm going to rewrite y squared minus 6y plus 9 as a binomial squared. That's going to be y minus 3 quantity squared. And what do I have on the left? 36, -36, add to 0. I just have a 4. Okay, I'm not done. In order to be a hyperbola in standard form, my equation has to equal 1. It clearly doesn't equal 1, it equals 4. So what I need to do is divide every single term by a 4. So my final answer is the quantity x minus 2 squared over 4. This is going to be a -1. I'll just leave it as minus. Quantity y minus 3 squared over 1, that's important to put there, equals 1. And this is my final answer in standard form. The other thing I know is that this is a horizontal hyperbola. Why do I know that? I know that because x, which is the horizontal axis, comes first. I know that a squared is equal to 4, which means a is equal to 2, because remember that the a squared term always comes first. I know that b squared equals 1, that's my b squared, and that b equals 1. Okay, I hope you found that helpful. I'm going to do another example in the next video of a similar type of a problem. Actually, before I go, I'll say one more thing. I do know that the center is at 2, 3. And if I wanted to, from here, I could find the vertices, the co-vertices, the foci, and all of that stuff. So I'll leave that to you to try if you like, and I will see you in the next video.